with Geomagic Technologies, one of our engineers, and we're going to go over the HandySCAN 700, which is our most popular 3D scanner that we carry. So we've got multiple models. This is going to be our fastest, most portable option. So, are we still running? All right. So, what makes this guy so portable is we've got the scanner itself is less than 2 pounds, less than a foot long, and the entire package that we're going to use for scanning is right here in front of me. So we've got a laptop, we have our carrying case with our scanner. Carrying case houses the scanner, the cable itself, our power supply, along with the calibration plate, along with a few other accessories that you may need. So I've actually got this running off of a battery pack, which is an option that we recommend. Let you go completely powerless for the duration of the laptop power supply. So to run through the specs on the scanner, other than the actual dimensions here, our accuracy is going to be 30 microns, or about 1 2/10,000, so that's 0.0012 inches, making this a true metrology grade measurement device. We can hold that accuracy in the field, which is very unique to optical, to any of this optical equipment, because we dynamically reference the part. So as the part moves, as the scanner moves, we can track that movement and we can hold everything to that just over 1,000th of an inch, as opposed to old equipment that maybe had to be mounted on the floor solidly or on a granite table in a controlled environment. As soon as you go outside of that environment, those numbers are all for nil. So we'll go ahead and go through the go ahead and go to the live scanning here. We go ahead and close this up. So our first part here, I've got a transmission housing. All right, I got a transmission housing here. So as you can see, we've got targets on the part. Now what these targets do is they tell the scanner where it exists about the geometry of this part. So when I start scanning, you can see that my laser projection lines move across the part, and the 2 lenses on the scanner actually track those. So you can see there just how fast we're gathering data on this. So we've got 7 laser crosses or 14 laser lines, however you want to look at it, and they're taking 400 up to 480,000 points per second. And we have a disconnection because we're live, so let me go ahead and click OK. All right, and we'll get right back to scanning. There we go. Okay. So we're going to fill in all of our geometry, and then you can see I can physically move the part, I can physically move the scanner itself, and we can keep track of everything that way. Now, if you say, okay, we get done, you know, I move around to the front if I need to. What do I do about the bottom side? I've got the top here. I'll fill it in a little bit better. All right. Got our targets still on our part. So we're going to go right back into scan. You can see there I haven't lost reference, I haven't lost anything, and now I can fill in the top of the part. There we go. We're going to finish that. Maybe if I want to grab some of the geometry on the back side, we can do that as well. But that's in a nutshell how the scanner works. So one last thing to cover on the 700. So we do have the 2 lenses that track the laser module, and we have those 7 laser crosses. Now, if I were to double click on the back of the scanner here, you can see we've got our single laser line. So what that does, it's a very cool feature. It actually turns off one of the lenses, so we don't have this very wide field of view. We can do a lot narrower shot, so we can get down into a lot deeper geometry. Down in the holes, we can generally get about twice the depth of the diameter of the hole. So we can get very far down in there, a lot farther than most other units. All right, so that's the scanner. Now we are direct to mesh. I'm gonna go ahead and shoot another part. So let's reset this. Go to a little bit different part. So we're direct to mesh, which is different than most other varmint scanners and things like that. We don't go to a point cloud and then require an extra software package to convert that point cloud to a mesh. Creaform is direct to mesh. There's no messing around with that. That gets us the nicest, cleanest, most accurate data set that you can possibly have. So this is a little bit different. We got this part. I still have targets on it, but you say, what if I got a thin-walled part? How do I get to the other side of it? If I got a small part that I can't put targets on, how do I scan that? So we can do that by actually using just a simple fixture like this. So we got this Creaform turntable, I've got that targeted up, and we can actually go in and we can start scanning. And you can see there I've used the base of the part. I can go on one side, we'll get all this data here, and let me go ahead and increase my shutter speed a little bit. So it's sort of like a camera where you do have to play around, increase those numbers if the surface is a little bit harsher to scan. So this guy's a little more of a translucent material, so we'll need a little bit of a bump in power there, but no worries on scanning most surfaces with this guy. So we're going to go to the back side. I'll rotate it around here for you guys to see. So again, I'm moving the part, moving the scanner, and because I've used this fixture, I can move all the way to the back and continue that scan until I've got 100% of the data, or enough data that I can actually inspect or reverse engineer the part. So that's a real quick rundown of how to do this type of part, something that's a little harder to just go from one side to the other. Very easy to do, it just requires a slight modification of your setup. All right. So, as far as the scanner goes, that's kind of the gist of how the unit works. Now we're actually going to go into using, what do you do with this equipment? So we've got the 3D geometry of the part. What are we going to do with that? Well, we can either, there's a number of different options. Our main two that we do here at Geomagic that we specialize in are inspecting items. So we're taking a part that we don't know whether it's inspect or not. We're going to scan it, and then we're going to run that against a CAD model. The other thing we can do is take that scan, bring it into a reverse engineering software, and recreate that CAD very quickly and very easily. So I'll run through those two options for you now, a full start to finish on both of those features. So let me reset my project here. All right. So first part is our demo. It's like a injection molded housing, plastic housing. So I've got the part targeted and I've got the table targeted. This part's big enough where I can do either one. All right. And if I go into scanning, again, I'm going to be using my my 7 laser crosses. So I want to gather as much data as I possibly can. Now we're going to go turn this around, and you see here I'm spinning it around on the table. I could leave it setting on the table. And again, because I can move this part, what's amazing with this, because the part can be under motion, is I can pick this up and I can continue scanning while I'm holding this in my hand. No accuracy loss at all. All right. When I'm happy with my data set, which I am here, I think that's enough to get what we need. I'm going to come over here to the computer. All right, and we're going to cut out all the trash that we picked up there. So we got some of the table, very easy to cut out. Let's go ahead and select the table there. I don't want that, so we're going to delete it. I got some noise in there from my hand, but most of that should be gone automatically as well. So let's go ahead and get out of our scan. All right, so this process here, what's actually happening is it's taking all those points, that 480,000 points per second that's been gathering, and it's going to take a portion of those, convert them into a mesh. So, and we can convert that mesh as much as we want. Those points are always saved in the background, so we can increase or decrease resolution as much as we want, play around with our scan settings, does not matter. Now if I go to my triangles and wireframe, for those of you who are not familiar with what a mesh or an STL file, what we call it, it's basically a triangulated point cloud. So if I zoom in, I don't know if we can see that on the screen, but I've got a bunch of little facets all over this file. So you can see how clean this data is. And Creaform does a great job with their software. So along the sharp edges, their software leaves tiny triangles, which keeps a lot higher resolution on the scanner, on the mesh. And then on the areas that are in between, say the stuff that doesn't have a lot of geometry change, that's going to be decimated. So it's a smart decimation to streamline some downstream processes. All right, so I'm going to go ahead and export this. So we're going to export the mesh, and we'll just call this part 1. Okay. So I'm going to switch screens. This is VXelements. This is Creaform's acquisition software. It comes with the scanner. It's not an extra add-on or anything like that. Every scanner ships with this software. Now, if we're to reverse engineer or inspect the part, we have to have another module or another software to do that. So I'm going to switch over. Our two premium options are by Geomagic. So we've got Geomagic DesignX, which is the reverse engineering, and Geomagic ControlX, which is the inspection software. So I'm going to inspect this part. I've got a program already written in ControlX, show you just how fast and easy it is. Just took us a minute to take a scan. All I did was export it, and now I'm going to bring it into ControlX. So you see here, this is the software that we're looking at. So I've got my CAD model here. Let me zoom in. And I've got all my features. I've got cylinders, I've got measurements, angles, everything that I need extracted without the scan in there. So it's ready to go, just like if you're writing in a CMM program or something like that. Now, I'm going to import that mesh. Okay, and you can see there it is. And I'm going to go ahead and let this process run. So it'll just take a minute. I'm going to click this, and while we're letting that run, I'll go ahead and start scanning the part we're going to reverse engineer, just to kind of keep things flowing very well here. So let's go ahead and click that. This is going to run for about a minute. So let's switch back to our software here, and we're going to do a new scan. So we talked about having a part that's too small to dot. So this is our demo part for that. What I'm going to do is just set it right on the table. You see the table is dotted again. So we're going to put the part on the table. The part does not need to be targeted. We don't need targets on the part. We just need to have targets around that part. So I'm going to go right back in, start scanning again. And again, all the controls, they're actually on the back of the scanner, which makes this very nice. So you can see when I start scanning, I can zoom in and out on the back of the scanner. I can start and stop my scan. I can switch to single line mode that we talked about. All that is done right there. So there's not too much need to actually go to the computer. Makes this very nice for scanning on the shop floor when you've got a lot of geometry, a lot of stuff you've got to work around. So I know the bottom of this part's flat, and it's on the flat table. So I'm going to use the table itself in the reverse engineering software in DesignX as part of my modeling process. So I'm going to make sure I get the hole as well. All right, and let's see here. I think we're good to go. So again, I'm going to go to Edit Scan. I'm going to cut out some data before we process anything. Okay. So I want to keep about that much of my data. So we're going to delete the rest of it. Okay. And let's go ahead and get out of our scan here. There we go. There's our new mesh. It looks pretty good. I'm not going to do too much else to it. We're just going to export it again. So we're going to export that as I'm just going to call it part 2 and save. All right. So let's go back and check on our ControlX program. If we look at our part and we zoom in, I've got everything filled in now. I've got measurements. We've got diameters. We've got distances, angles. Those are all filled in, all color coordinated, whether in or out of spec. You can see that a thing that a lot of people are looking for is this color gradient. So I got a datum alignment done on this part, and you can see here with the datum features I've chosen, half of the part is out of spec. So it tells us very quickly if there's anything wrong going on. Extremely useful, way faster than doing this on a CMM, where you may spend an hour waiting for it to probe or more to take all that data. We scan it just a couple minutes, and we got 100% of our parts inspected after the program got run. All right, so, and once we're done here, the only thing we got to do is generate our report. So let's go ahead and click that button. All right, I'm going to select a few things I don't need in the report, and we'll show you just what that looks like. So it's going to propagate everything we have in this tree into a long spreadsheet that we can then send to our quality control manager, to customers, to clients, let them know that your parts are good to go. So this is what we're looking at. And this is all customizable, but I've just got the default of the one that I've come up with that tends to look pretty good. So we've got our CAD file, our mesh, our datum alignment features, so it outlines the features there. We've got cross sections, so that's actual physical cross section through the mesh with 2D dimensions. We've got a cross-sectional deviation color map. It's probably a little hard to see, but what's really cool is the 3D color map. There we go. So that's, again, something that everybody looks for. All right, and then all of our 3D dimensions. So all that's propagated into this, and we can program this however we want to make it look good, organize, everything like that. So that's the inspection software, a real quick snippet of that. Now, what I'm going to do is we're going to close this. This is ControlX again. We're going to go to Geomagic DesignX, which is our reverse engineering software. We're going to actually reverse engineer that part that I just scanned. So let me take a seat. All right. So let's get out of this. Now this is DesignX, so it looks very similar. Both of these are laid out, ControlX and DesignX are laid out like CAD programs, so they're very easy to transition to. Now I'm going to import that new part, so part 2. Okay, and then here we go. So there's our mesh. Now what I want to do is I have to align it. So it's not aligned yet, it's just floating in space. So you can see our top, front, and right planes. So I'm going to run what's called a region segmentation on this part. And what this does is this goes through and identifies planes. You see plane cylinders, things like that, free-form surfaces on our mesh. So if you hover over, we can highlight different features on the mesh, and that'll kind of, this is going to drive our reverse engineering process. It's going to let us very quickly extract these features. All right, so first thing I need to do after this is align the part. So we need a couple features to do that. I'm going to go ahead and create those. I'm going to put a point. I'm going to put a point on this center here, but what I'm also going to do is throw in a plane. Now, I don't need the region groups yet, so let's go ahead and grab our plane tool, and I'm going to create a center line, a center plane down the part. All right, there we go. There's our plane, and now we're going to do what's called an interactive alignment. So I'm going to go to my alignment tab. I'm going to choose a plane, I'm going to choose a vector, and I'm going to choose a position, which is that center point. And now my part's aligned. We've got our coordinate system here. If you need to maneuver that stuff around, you can. But now if I look at all my features, my front, top, and right plane, if you can see that, we are perfectly aligned to our CAD coordinate system. All right, so what do we do from here? We've got to take this mesh and generate a CAD file. Unfortunately, there's never been a one-click button to automatically extract a CAD file. We need to tell the software, we need a little direction of what we want. So this is as close as we're getting that, and you see just how fast it is. We're going to use what's called our Extrusion Wizard, and we're going to actually select the regions that encompass the part and automatically extract these solid portions. So I'm going to choose the top is the top free form, the sides, and the bottom is our table that we scanned on. All right, and then I'm going to designate that the extrusion direction is our front plane. So everything I'm going to do that way we ensure everything is square, everything is extracted correctly. Now when I click the next button here, there we go. So it's gone ahead and created generated a preview. When I click the checkbox, you can see we've got our first body created. So I need to do that a couple more times. I'm going to do that here. I'm going to go back to my Extrusion Wizard. We're going to grab the sides of this cutout. There we go. I'm going to leave the top open because we don't have a top. I'm going to use the bottom. It's going to be this region, this recessed region, and then we should be good. I'm going to change this to solid cut. And when I click my checkbox, there we go. We've got our cavity cut. Last thing we're going to do that with is the cylinders. So we can do all those at once, which is very nice. So we can grab the sides of all of these cylinders. All right, choose our extrusion point. There we go. And tell it to cut those pieces from our CAD file. All right, there we go. So this is, you can see just how quick we've already extracted all this. The best part about this is we are building this parametrically. So it didn't just give me this file and out of nothing, right? You know, maybe you want to go back and make some design changes. It has created a plane and a sketch for every single one of these functions. So let's go into our sketch here. For our cylinders, I can go in, I can dimension that. So 0.2945, I can make that 0.295. Let's go ahead and make that a real number. We've got all of our same sketch tools and our constraints and things like that you find in any other software. All right. Last step I want to show you is what we call a mesh sketch. So a little more of a manual option, but we're going to do that on this last cavity here. So let's hide everything. There we go. And what I'm going to do here, I'm going to sketch right on this region, so it's going to let me do that. All right. And the pink line, if you can see them on here, is an actual cross-section of the mesh itself. So those are our reference polylines, and I can do a few different things. I can go ahead and snap features onto those. I can also use the auto sketch function and just click on those features there and go ahead and fit a quick sketch. So click my checkbox, do another extrude. Let's get out of my sketch here. Do an extrude cut. All right. And there's our nearly completed model. Needs a couple fillets. I guess I'll go ahead and show you that. Here we got our last feature is this fillet. So if I want to fillet around this edge, it's very cool. So I can change this value obviously to whatever whatever value I want. We can make that half an inch if we need to. Now we can actually let the software tell us what that radius is. So we've got a little estimator tool here, and it's going to go find out what it thinks that radius is, press it down onto the mesh, and it gives us back 0.0983 inches. So maybe I want to go ahead and standardize that. That tells me very closely what it is. I'm going to make that a 0.1 inch radius. And that is it. So there's our part fully reverse engineered in just a couple minutes. That's the entire process. I think we're good to go here. So you can find us if you want to learn a little more about everything, about the software or the equipment. You can either find us on www.3dscanningservices.net. That's our website. Again, we're Geomagic Technologies. Or you can call in 888-696-7226, and we can answer any questions and work out whatever we need to with you. So thanks for tuning in. You guys have a good day.